Hi, welcome to Ashok Kumar channel Physics. Today we are going to discuss about total internal reflection. Actually, reflection is caused by opaque objects, but we are studying the total internal reflection in the process of refraction, that is by the transparent mediums. How do the transparent medium will reflect the light? So actually reflection is caused by the opaque objects, but here we are discussing reflection caused by the transparent mediums. For that one, we need to consider object must be in the denser medium. Why we need to consider object must be in the denser medium? So you are going to get that concept early. Suppose for that one, I'm explaining with an activity. Suppose if this is an aquarium, let us assume this is an aquarium. Okay, suppose if there is a light source inside the aquarium, if I place a light source here, okay, so then light is traveling from aquarium to air. So aquarium is surrounded by the air, so this is said to be the rarer medium, air is said to be the rarer medium, and in the aquarium there is water, so water is said to be the denser medium. As light source is in the water, then light travels from water to air, that is from denser to rarer. When light travels from denser to rarer, so this is the incident ray from the light source. Okay, so this is the interface which is dividing aquarium and air, water and air. So at this interface you need to draw a normal, because it is going to deviate with respect to normal. How it is deviating? So this is a denser medium, this is said to be the rarer medium. If a light ray travels from denser to rarer, it bends away from the normal from the original direction. This must be the original direction. From the original direction, it moves away from the normal, it bends like this. This is the refracted ray. This is the angle of incidence, angle between incident ray and normal. This is said to be angle of incidence. Angle between refracted ray and normal, this is said to be angle of refraction. Okay. If you rotate the light source, if there is a mechanism which can rotate the light source, suppose if I can rotate the light source, what happens? If you are rotating the light source means what you are doing, you are increasing the incident angle. Why? At this point of incidence, if you draw the normal, now what happens to the angle of incidence? Previously this is the angle of incidence. Now if you see, we have seen angle of incidence has increased. As the angle of incidence increase, what happens to the refracting angle? So it is traveling from denser to rarer, so it bends away from the normal from the original direction. This is the original direction. It is going to bend away from the normal like this. It is going to bend away from the normal. Now this is the refracted ray, angle between refracted ray and normal. This is said to be angle of refraction. See, as you are rotating the light source, you are increasing the angle of incidence. As the angle of incidence, angle of refraction also increases according to Snell's law. And next, if you further rotate the light source, what happens? If I rotate the light source further, now this is the incident ray, and this is the point of, at the point of incidence, if you draw the normal, this is said to be the angle of incidence. As we have seen, this angle of incidence and this angle of incidence, we can see that angle of incidence has increased. So this is the original direction. From the original direction, it has to bend away from the normal. As it is bending away from the normal, it is going to graze. It is going to bend away from the normal. Bending means it is going to graze on the surface of water. On the surface of water, it is going to graze. Now this is the refracted ray. And angle between refracted ray and normal, this is said to be the angle of refraction. How much is this angle of refraction? You are going to get as 90 degrees. And this angle of incidence in the denser medium, where the refracting angle in the rarer medium is 90 degrees. That angle of incidence is called critical angle. Now you can define the critical angle in your own sentence. Where is you are getting the critical angle? Critical angle I am getting in the water. That is the angle of incidence in the denser medium. where the angle of refraction becomes 90 degrees in the rarer medium. That angle of incidence is called critical angle. Now you can write the definition. We get a definition that is said with the critical angle. If you further increases angle of incidence, what happens? If I further increase the angle of incidence, that means I have to further rotate the source. Now this is the angle of incidence. I can see this angle of incidence is greater than this angle, which is called the critical angle. Now this angle of incidence is greater than critical angle. Then what happens? So if you see, it is bending like this. First it bends, then it bends like this, then grazes, and next it is going to internally reflect, which is done by the refracting surface. So here the refracting surface will also do the reflection when the first condition is object must be in the denser medium, then light ray travels from denser to rarer. So that is the first condition for the total internal reflection to be happen. Object must be in the denser medium. By placing the object in the rarer medium, you cannot expect the total internal reflection. So you will get the total internal reflection only when the light travels from denser to rarer. That is, object must be in the denser medium. And next, when do you get total internal reflection? If angle of incidence is less than critical angle. So ikkada angle of incidence, so that means at this place angle of incidence is less than critical angle. Here and here angle of incidence is less than critical angle. Then what happens? You will get the refraction. If angle of incidence is less than critical angle, then you will get refraction. We are getting the refraction takes place. If angle of incidence is equals to critical angle, then it grazes, not total internal reflection. If angle of incidence is equals to critical angle, then ray grazes on the surface of water. Next, if angle of incidence is greater than critical angle, then only you will get total internal reflection, which is said to be TIR. TIR, total internal reflection. So this is when, these are the conditions, you need to get the conditions. This is also an important question. So if object is in the denser medium, when do the refraction takes place? If object is in the denser medium, refraction takes place only when angle of incidence is less than critical angle. When do the light grazes on the surface? The light grazes when angle of incidence is equals to critical angle. At critical angle, total internal reflection does not take place. When do you get total internal reflection? If angle of incidence is greater than critical angle, then only you will get the total internal reflection. When do you get the total internal reflection? If angle of incidence is greater than critical angle. So now these are the two conditions. So you are having a very important question is there. What are the conditions for the total internal reflection to be happen? The conditions are first, already I said, object must be in the denser medium, then light travels from denser to rarer. That is the first condition. And next condition is angle of incidence must be greater than critical angle. Then only you will get the total internal reflection. So when the reflection takes place, you need to apply the reflection rules. That means angle of incidence is equals to angle of reflection. Reflection takes place, I need to apply the reflection rules. Then it is going to total internal reflect. It is going to reflect like this. Now this becomes the incident ray for this surface. For this surface, this is the incident ray. So at this point of incidence, if you draw the normal, now this is the normal. Okay. Suppose if this angle of incidence is also greater than critical angle, then it is going to total internal reflect. Again it is going to total. Now here also light is traveling from denser to rarer. This is water, this is the air. So this is also a transparent surface. If it is traveling from denser to rarer, if this angle of incidence is greater than critical angle, again you will get the total internal reflection. So again you are going to get the total internal reflection like this. Now this is the incident ray for this surface. Now the light is traveling from water to air. So if this angle of incidence is also greater than critical angle, this angle of incidence is also greater than critical angle, again you will get the total internal reflection. So that means the light is bounded within the denser medium. and there are multiple reflections are taking place. Multiple. All together we will call these multiple reflection, all together we will call total. There are so many multiple reflections, all together we will call total, and it is internally reflected within the denser medium, internally reflected. That's why it is said with the total internal reflection. So then how do you find out the critical angle? So different mediums exhibit a different critical angle. So how do you find out the critical angle? So in order to find out the critical angle, where does I can find here at this point I can find the critical angle, because this is the critical angle. So as the refraction takes place, you can apply Snell's law. So if you apply the Snell's law at this point of refraction, then you will get the total, so that is critical angle. So as the light is traveling from denser to rarer, so if this denser medium is having refractive index mu2, if you consider, and if the rarer medium is having refractive index mu1, so always assume rarer medium refractive index is mu1, denser medium refractive index is mu2, so that you are not going to get confused. And it is not compulsory. So should I consider denser medium refractive index always mu2? No need. You can consider as mu1, rarer medium refractive index you can consider as mu2. But for your convenience, I am saying, without getting confusion, always assume rarer medium refractive index as mu2 and denser medium refractive index as mu1, so that you are not going to get confused. So now I am applying the Snell's law at this point of incidence. So what is the Snell's law? Snell's law already we said, sin I by sin R is equals to refractive index of second medium by refractive index of first medium. Second medium is nothing but where the refraction takes place, that is said here. Rarer medium is the second medium. So light is traveling first in the denser medium, second in the rarer medium. So rarer medium is the second. Refractive index of the second medium is nothing but rarer medium by refractive index of the first medium, which is the denser medium, mu1 by mu2. Denser medium is the first and rarer medium is the second. It is traveling from denser to rarer. Then sin I, this angle of incidence is called, we are applying here, this angle of incidence is called critical angle. In the place of I can substitute as C by, what happens to the refracting angle here? This here refracting angle is 90 degrees, so R is 90 degrees, and then sin 90 is 1 is equals to refractive index of rarer medium by refractive index of denser medium. So this is the formula to find out the critical angle. Sin C is equals to mu1 by mu2. And we have a very familiar condition, that is if the rarer medium is air, if it is traveling from water to air in this condition. So if the rarer medium is air, so for air mu1 is 1, for air refractive index is 1. If you assume that one, then sin C you will get as mu1 is 1, and if you assume refractive index of the denser medium as mu, that is mu2 is equals to mu, then you are going to get the sin C as 1 by mu. This is the formula to find out a refractive index of any medium. So not refractive index, to find out critical angle of any medium. So you are going to get the critical angle which is inversely related with the refractive index of denser medium. So as the denser medium is having more refractive index, then critical angle is less. As the denser medium is having less refractive index, then critical angle is more. So if it is having more refractive index, critical angle is less, means here only total internal reflection takes place. So that means critical angle is less, means at this angle of incidence it is going to get the total internal reflected, or at this angle of incidence it is going to get the total internal reflected. So critical angle is less means for the less angle of incidence you will get the total internal reflection. That means the total internal reflection takes place quickly if the denser medium is having more refractive index. If it is having more refractive index, then critical angle is less. That means the total internal reflection takes place quickly. So that's why diamond shines more. Why? So if you take a diamond and a glass, you can take a quartz glass or any type of the glass. If you take a diamond and a quartz glass, both are transparent mediums. If you cut them in a shape, equal shapes, so then which shines more? We always know diamond shines more than a glass. Why do diamond shines more than, even though both are transparent surfaces, even though both are in the same shape, why do diamond shines more than a glass? Because compared to quartz glass, diamond is having more refractive index. The refractive index of diamond is about 2.4. Of all the transparent mediums, not all the one, we are talking about the transparent mediums. So of all the transparent objects or a transparent medium, which medium or which object is having more refractive index is diamond. Diamond refractive index is 2.4. So as it is having more refractive index, the critical angle for diamond is less. That means in the diamond, total internal reflections takes place quickly. That means more number of multiple reflections takes place in the diamond than the quartz glass. As the reflections are taking place quickly, then you will get a bright spots wherever the reflections are taking place. That's why diamond shines more than a glass, even though both are cutting in the same shape. So that is the question also. What is the reason for brilliance of diamond? The brilliance of diamond is nothing but it's a shine. Why do diamond shines more than a glass? Because the diamond is having more refractive index, and as it is having more refractive index, its critical angle is very less. As it is having very less critical angle, total internal reflection happens very quickly. As the total internal reflection happens quickly, then you will get more number of multiple reflections and more number of bright spots you can see. So that is the reason for a brilliance of diamond. Okay. And the condition, you need to remember the condition. In order to total internal reflection to be happen, object must be in the denser medium and observer must be in the rarer medium. And angle of incidence must be greater than critical angle. So this is about the total internal reflection. Then in the next class, we are going to see what is the mirage. How do you get the mirage? Mirage is nothing but we can see there is a water in a hot summer day at a distance, but there is no water. It's just an illusion. We can see on the road. So if you walk on the road in the hot summer day in the afternoon, so we can see at a distance it looks like there is a water, but there is no water if you go there. That is just an illusion for our eye. Why do this happens? And in some cases, in the cold countries, we can see objects are floating in the air. That is also an illusion. So for both cases, we will explain based on the total internal reflection. So this one we are going to see in the next class. Thank you for this class.